Okay, so correlation. So with linear models, there's at least 5 options here. So um, when x is increasing and y is increasing, so if I were to put say a line of best fit to this data, it might look something like that. That's a pretty good fit. So this is positive, as in it's a positive relationship, kind of like we were talking with direct variation. As x is increasing, y is increasing in a proportional way. And this is very strong too. So we would describe this as strong and positive correlation or relationship there. This one has a positive correlation as x is increasing, y is increasing. But this you might call weak or moderately strong. Sometimes we use words like that. Certainly not strong because the data doesn't follow as closely. It's definitely a positive pattern, but it's not as close. This would be definitely a negative correlation as x is increasing, y is decreasing, but it would be a strong. You would describe it as a strong uh, negative correlation. This one would be a negative correlation as well, but this one would be weak or at least moderately strong or moderate. Um, and so this one really doesn't seem to have a pattern. So we just say something like no correlation here. If we did try to do a correlation, I guess it would be kind of like a horizontal line with a slope of 0. So there's no real positive or negative correlation there. So sometimes things will have no correlation at all. So just you can't do it. So for this activity, for today's lesson, you really need to use your calculator, even more so than the book says. I want you to be able to use your calculator to enter the data here. So on your calculator, hit the home key at the top right and go to the List and Spreadsheets app. I like to name the list. So I'm going to call this one temp. I'm going to call the next list at the very, very top share sales. Okay, so the temperature was different temperatures, 75, 80, 85, 90, 95, 100. By the way, you may notice this. I typed 100, but I haven't pressed entered or moused out of the cell at all, and it doesn't know I typed it. If it knows you typed it, the number will be on the right-hand side of the cell. Sometimes students will enter a number, but they won't actually press enter, and the calculator doesn't know until you either press enter or kind of arrow out of the cell. Go back up to the first cell here, says 2400, 3000, 3450, 3750, 4100, 4500. Okay, and notice I moused out of the cell. You could even put your cursor in the next column would be fine. So I typed in all the data. So I'm going to go, this is kind of neat, it's kind of fun. So hit the home key, go to the Data and Statistics app. It looks kind of like a bar graph, and click that one. And the data is just kind of randomly up on the screen. If you press tab or click at the bottom of your screen, I guess the X value would be the temperature. And it nicely scales it, kind of puts a dot plot there. The temperatures are all spread out. If you hit tab or click on the very left, there's kind of a spot there. Click to add variable and choose sales. And so, wow, it does a scatter plot of the data for you, which is kind of neat. So it scales it really nicely. You can tell this data looks, I think it looks, if I had to describe it, probably strong and positive, right? So, and the calculator can do more. It can figure out the line of best fit. So it has a thing in there. So I think it's under analyze. If you go to regression, so it can do a linear regression. There's 2 types. I would choose the first one, mx plus b, but you could certainly choose the second one. It's the same equation, just a different order. So mx plus b, it graphs it for you. It says that's the equation of the line. If you really want to get into the weeds here, let me see if I can do this. Menu settings. If you choose diagnostics and say, okay, it'll actually give you the R squared value. We don't know what that is yet. Roughly speaking, if that R squared value is very close to 1 or -1, it's a very strong fit. And this is 0.987, so it's very close to 1. So it's a pretty strong fit for the data there. And another nice thing about this that the calculator does is it kind of stores that equation, that y equals regression equation is stored in your calculator. So let's just say, for example, I wanted to make a prediction, like what if the temperature, this would be kind of crazy, what if the temperature was 105 in Memphis? Well, if this line of best fit is still there, we could make a prediction here. So to do that, you want to hit the home key and don't go to the scratch pad. Don't go up there. Go to the calculator page. So that will be communicating with your listen spreadsheet page. It also communicates with the data statistics page that you just did the regression on. In fact, there's a cool key you can hit, which is the variable key. And the stat reg equation is what it's called. And so I'm going to plug in 105 and see what it does. So the answer is that. Let me show you what it's doing. So let me go back to the equation here. So this was y equals 80.57 approximately. I just kind of cut it off there. Times x plus or minus, I guess, plus negative 3516. 3516.67. So that's our regression equation. If you plug 105 in there for x, and you can do that right now, you will get this as an answer. So plugging, that's this equation. If you plug in 105 for x, you get y equals, which by the way, y is like the Sheridan's, x is like the temperature. So y equals 4943.33. So 4943.33. So the sales you would expect to be very close to 5,000 if it's 105 degrees. Now it's hard to predict too much into the future, or future in this case, you know, to extrapolate too far away from the data. What I mean by that is hypothetically, I don't know if this is possible. I mean, California's on fire right now, but let's just say it was 160 degrees. Your calculator could make a prediction on that. Whoops. So let's see what it predicts here. So I'm just going to type it in because this line of regression can make a prediction. It would predict 9,300 sales, but really if it's 160 degrees, I don't know what would happen. That would be crazy, especially in Memphis with the, oh my goodness, I can't even think about how hot that would be. So I don't think people would even be going out for ice cream. It would melt almost instantaneously. So that would be tough to eat the ice cream. You have to eat really fast. My point is, it's probably not wise to extrapolate too far out, but a little bit out. I think that's okay. And also, we could do so we could guess like 93, right? So if you kind of plug that into, whoops, keep doing that. If you plug that into the equation, so I'm gonna plug in 93. I'm probably expecting some number. Let's see, 3976. 3976. Yeah, that makes sense, right? Something in between 3,750 and 4,100 would be a good prediction for that number. So the calculator can take that equation, plug the number in for you, and find that line of regression for you. So I want you to try it with this data. So we're going to go, this table lists the average monthly temperature here. So this data is from 2008. How would you describe the correlation? So average temperatures and electricity costs. So you can get your calculator out. One way, it's kind of a cool way to do this, if you hit the dock key, you can insert a new problem. What that does is now I'm on page 2.1. I'm going to go to add list and spreadsheet, and all my variables are new. So for this page only communicates with other pages like 2.2, 2.3, so forth. So I'm going to call this one temp again because it won't populate with my old data because I inserted a new problem. Go to column B, I'm going to say a bill for electricity bill. You use a name, just call it, something. And so 61, hopefully I'll type these all right, 58, 67, 75, 9, 83, 84, 85, 81, 76. Helps me to say I'm 58. Okay. Okay, and then in column 2, it's going to be all the electricity bills, 150, 139. You would think I don't know, maybe not all to temperature, because maybe in the wintertime it could be like maybe a lot big bill when the you need to use the heat a lot, I guess. So it's not just air conditioning, because I think it's electricity, so it depends. This could be interesting. Let's see, 132 and 112 one time. Okay, so I got all the data I got out of that last cell that's important. Hit the home key, go to data statistics, hit tab or choose down there, and you want temperature, I guess, for your x-axis. Hit tab and choose the bill for your y-axis. Oh, that's pretty cool. Okay, so this is positive. Yeah, the hotter it is, the more electricity, but it's not as strong. So I would say it's positive, but I would say it's weak or moderately strong, something like that. I know that sounds funny, but you can actually do sometimes both answers. And you can see the R squared value is 0.83, which is not as close to 1 as 0.98 was, right? So this is definitely not as strong for sure as the other one. And again, you have your bill. You can use that to make predictions. So we could make a prediction even the other way, right? So we could plug in. So if I add a home key, home, and add a calculator page, again, you go to variable, regression equation, stat regression equation. If I asked like 40 degrees, we could predict that the bill would only be $48. It's pretty cheap. At least for the AC, I guess, but maybe some point you might have to start using. So what could I do? See, but sometimes, like if you make a prediction, like so, let's say 0 degrees, that'd be pretty cold, right? Oh yeah, I don't think that's possible, right? So the don't predict too far out of the range of the data you have, or the answer may not make sense. That doesn't make sense. They're not going to pay you $117 for your electricity bill, which is what you pay now. So that answer, so it was extrapolating too far away from the data. So you can use it to make predictions. It's better for making predictions inside of the data. So if I, said like 80 degrees, which is kind of like in between some of those data pieces, about $214 bill or something like that. So you can make predictions inside the data or outside, extrapolating, interpolating. You do that a lot on the ACT science section, actually. And then you can do some more of this. Again, it's just a matter of, use the equation to predict the median home price in 2020, which is, a somewhat reasonable number of years ahead. So that might be possible. Home prices have really changed since 1940. I think my house I grew up in was around 15,000, but then they sold it for over 100,000. So over the years they had it, which was, I think, 30 years or so, it went up quite a bit. And that's what happens to homes. They start lower and then eventually they go up quite a bit higher. So that's the lesson for today. Again, you would just keep doing more of the same. I've taught you how to do it. So now go do it on your homework.